DFG Science TV, a polar climate archive. Dwelling in the Arctic, climate research for the future.
Lake Elgagitgin in Siberia. The insights gained from there are not only exciting for the researchers from Cologne. Its lacustrine sediments represent the climatic history of the past 3.6 million years. This history can be reconstructed from external organic inputs such as pollen, but also from the remains of microorganisms such as diatoms once living in the lake. Bernhard Chapligin is a doctoral candidate at the Alfred Wegener Institute in Potsdam. The main focus of his investigations is the oxygen isotope analysis of biogenic silica from a unicellular algae, for a good reason. The skeletons of this silica-secreting algae, namely diatoms, preserve the ratio of light to heavy oxygen in their silica-oxygen structure prevalent when they were alive. The Isotope Laboratory in Potsdam is one of 8 institutes globally known working on a method to tap into this structure and analyse the released oxygen, the preserved past climate, in mass spectrometers. For this purpose, the researchers need a diatom sample as pure as possible, aiming at a purity degree of 97% plus and higher. The geochemists therefore extract the diatom skeletons from the sediment samples in numerous physical and chemical purification stages. This is done among other methods by using heavy liquid separation and then using a mixture of perchloric acid and nitric acid. The aim is to separate the sample from the residual microorganic remains. The samples are put into a warm water bath at approximately 50 degrees Celsius for around an hour to accelerate the acid reactions. A centrifuge separates the diatoms from the added fluid at 2500 rpm and washes out the acid. This process is repeated 6 times and results in a purified diatom sample from which the supernatant is decanted. The remaining algal skeletons are dried and readied for contamination assessment. So-called stamps are prepared for the scanning electron microscope in order to examine the purity of the samples. This microscope allows a theoretical magnification of up to 1 million times.
This
is not an easy undertaking. It involves a great deal of preparation and a lot of analytical effort. The overall process has its problems and challenges, but we're on the right track now to make it work, and hope we can reconstruct the oxygen isotope record of the water. The dry, pure diatom powder is filled into small vials and weighed. Here it's already possible to see whether it was taken from sediments from a warmer or a cooler phase. The warmer the climate, the more diatoms are produced, and the higher the bioproductivity. A nickel plate is prepared by adding powder from several diatom samples. The doctoral researcher also adds standards, which provide reference data. Hydroxyl groups, which could distort the results, are removed in a helium-percolated furnace at 1050 degrees Celsius. This process takes 6 hours. Only after this, the final stage before the analysis can be completed. Using a laser beam, every single sample on the algae-filled nickel plate is vaporized. The resistant silicon-oxygen bonds are cracked with the aid of the highly reactive gas bromine pentafluoride. The released oxygen is transferred along an approximately 3-meter path to the mass spectrometer. So-called cold traps at -196 degrees Celsius keep undesirable gases out of the instrument. The ratio of heavy to light oxygen can then be measured. Based on the acquired data, the scientists hope to draw conclusions on how warm or cold it was during the respective period and what the prevalent wind systems were. One of the goals is to compare our proxy data to other measurements. There are so many people who analyse sediment cores, and we're one of those species, meaning the oxygen analysis of diatoms. This data will be compared to others, and the results together give us this broader picture. What was the past climate like? In the meantime, the core logger from the Geoforschungszentrum is being installed in Cologne. More about the data it collects and what they mean will be revealed in the next episode.
Visit DFG Science TV for more information. Awaken the researcher within you.